applause going for exploitable security architecture mistakes that we just keep making with William.
Hey there. I'm very grateful to be here. I'm very flattered, actually, that I got chosen. I do have some slightly small stuff on my slides, and I checked beforehand. If you're on the last 3 rows, you might want to go load that URL there to see the slides up close, or you can come forward. Your choice, but fair warning. So yeah, I wanted this talk to be about like pragmatic things. Ooh, closer. Close enough? Good, good, yeah. I wanted this talk to be pragmatic stuff for attackers and defenders. So that's what this talk is about. It's based on my experience working at SaaSes and attacking SaaSes. Anyone done either of those things? Not so many folks. Okay, well, for the looky-loos, I hope to make this interesting. Everything is real world, it's exploited end to end. So yeah, it's not theoretical. Cool, so what are we gonna cover? Fundamentally, we're covering executing code that we don't trust and doing it securely. We're gonna go over a few things, bunch of stories, again, real world, and we'll talk about what to do about it. So, a bit of context. Why are we executing code that we don't trust? That sounds like a terrible idea. Well, it might be, the really obvious form this takes is you're like Circle CI, you're doing people's builds. Yeah, I'm referring to builds a lot in this talk, but really what I mean is you've got some behavior you let your customers configure with code. So it could sound like pipeline if it's machine learning. It could be a preview if you're dynamically generating content. It could be a plugin. So it's not necessarily what your SaaS is doing front and center. But this is an increasing trend. SaaSes are doing dynamic stuff on the back end with code that they don't trust. And again, I'm seeing this kind of separation, this kind of trust boundary where you have a user running untrusted code and a root user running trusted code. What's important is the trust boundary is separate users. This is not about I got root, ergo game over. This is about I got to root and root has stuff that matters, right? And there's often at least one way to hijack the execution flow, so to cross that boundary. And there's a lot of good reasons why that happens. So we're being pragmatic here. So why do attackers want to do this? It's because root has access to stuff that you really care about. Maybe that root user can write directly to some Kafka topic somewhere. Oh my God. Or it has secrets to third parties. Or lots of stuff that you maybe didn't start out as having, but you accumulated over time, and that stuff's dangerous. And there's a lot of real reasons that adversaries want to exploit this trust boundary, and you're going to know best, you as the security engineer at a SaaS, you're going to have the best understanding of what motivates your adversaries. So, some feedback I got in this talk, thanks if you're in the audience, by the way, is that, well, how does this tie up to what's actually happening out there? And good news is hijack execution flow. There's a whole MITRE page on that with all the sub-techniques. Nothing here is new. I mean, everything I'm talking about has been around for a while, but it works. So, you know, if it's working for adversaries, they'll do that. And everyone knows that SaaSes don't provide CVEs, right? They're not necessarily going to tell you all the time when they've been breached. So while I can point at a whole bunch of CVEs that use these techniques and point at MITRE and say, hey, look, all these APTs are using these techniques as well, I'm really kind of squinting when I say, hey, this maps up to attack vectors on your SaaS. But I can say I've had really good luck using them. Cool. So I've grouped these into a bunch of different categories. I'm not covering everything. I'm just covering things that I've seen happen a bunch of times and things that I think are below people's consciousness, right? So I'm not covering a whole bunch of stuff that is prevalent that everyone knows about. So the first group is I've called path-like exploits. And there's a couple of different variants. So there's path execution order. I apologize for not having a whole bunch of transitions here. I've been lazy. So the context, which I haven't included on the slide, is you're a SaaS, you have a build, your attacker is using your front door, right? They're coming in through the service you provide. And they provide the attacker's coming along, they're triggering a malicious build, they provided their Git repo, right? and you, in good faith, are coming along, taking that Git repo, telling your untrusted user, again, this trust boundary, hey, go do that build. And the thing that that build does is it comes along and it says, well, damn. You know, obviously, the attacker's done some recon before, right? Oh, there's this thing on your path that's high up the path order. That directory doesn't even exist, but the attacker can create it. Create that directory, stick in a reverse shell, make the file executable, you know, claim that your build is done, hand back control to the root trusted user, right? And then as soon as it does any kind of cleanup work, in this case, execute tar, boom, because it didn't specify an absolute path, it's executing the wrong thing. You got control, right? And then you got to do all of those really bad things and exploit all the access that root user had to either inside your internal system or like pivoting to a third party. And I got to say, I get goosebumps when I kind of make these kind of hacks, right? It's kind of fun to exploit. And you might think, you're in the audience, think, I know how path works. No one would ever make this mistake. Yeah, maybe not to begin with, right? But you know, things evolve over time. This path that I'm showing you was huge. It was not as concise as this, right? So things do get a little bit hard to see. So another category of path lengths is there are a bunch of really obscure things that you can set on environment variables that control the behavior of things like Python and Node. Basically anything that's going to go dynamically get code to go execute. And this is an example of, again, I'm saying build, but think of it as any environment where you can come along and you give the attacker control over the environment variables that you're going to execute using. Yeah, that's just dangerous as all hell. In this case, Python path basically lets you say to Python, hey, when you need to go import a module, go here first. Sounds innocent enough, right? And if you go look at the docs, it's like a 2-line description that says this is where we get our code for modules. Yeah, so in this scenario, then the attacker says, hey, here's my build, here's my Python environment variable. And by the way, the malicious JSON pie is in that repo. It comes along, root comes along, prepares the environment, sets the environment variable, which is the big mistake, and then executes some of its own code that happens to be in Python. And then as soon as it hits the import JSON, boom, you've taken over control. And so what you're seeing on the right-hand side there is that that JSON pie is like basically a JSON reverse shell. And again, you might look at this and say, whoever does that? Nobody does that. And in fact, in this case, as I was reporting this in the bug bounty, I'm like, by the way, I can tell your engineers thought about this. And maybe even I'm thinking to myself, in response to something security said, you know, way down in the weeds is, oh, let's allow list what environment variables are set. But it was too late, right? Because upstream already set them. So you can, just a warning, you know, you can think things work the way they do. It doesn't matter until you go actually verify how things work. So what can you do about this? Like, the simplest thing to just be sure that you don't have this kind of problem is, in the case of path, is just set absolute paths on everything you execute. If you can make that be a criteria for how things work, awesome. If you're going to take untrusted environment variables, and this will come up again later, just set them at the last responsible moment. Right before that process that needs them, that's the moment you do it. So if you're using sudo to do that, that's what your syntax would look like. And really, even better is, because you know things are going to regress, you'll do your point-in-time review, and then later something's going to change, and by the way, now you do have a security vulnerability all over again. So any kind of compile time or runtime checks that you can have to enforce and fail early, you want those. That's what's going to help you sleep well. So now we're on to a different category. It's about exploiting Git client hooks and how they work. Full disclosure, I don't know that attackers are using this in the wild. I haven't seen it, but I have seen that it totally works again and again. And really this comes down to, like, engineers are familiar with client hooks for compilation. For right before they push up changes. It's like, hey, let's do this verification hook. It's going to go run my linting or run my tests. And so when they come to build systems in production and they worry about client hooks because they're thinking about it, they'll stick a -- no verify, and we're good, right? No. The docs are not super awesome. If you want to go find out when and where and in what scenario all the different client hooks will fire, it's actually a bit of digging. But there's two really great ones. One's post-merge when you're pulling, and post-checkout, and that will fire when you update submodules. So what does that look like? Same kind of scenario. You're doing some sort of work on behalf of your user, and you've given them the ability to tell you where their Git repo is, and you check it out. And in this case, he then does some work, and then the malicious code is going, okay, all right, we're going to do that same trick. We're going to prepare ourselves, pardon me, malicious script, and we're going to stick that in the Git hooks folder. So in this case, .git/hooks/postmerge. And as long as it's executable, and you return control again, and then later the trusted user root executes it, you're good. So there's normally a sequence of operations that matters here, right? All the Git stuff happens before you get control normally. Thanks. So you need some other little ingredient to make it all work. And in this case, kind of for the fast user experience, the SaaS, they kept all of this. They kept this instance live for a little while, and if you push up a change, they go, "Okay, we'll pull it down. We'll go update things." Right? Great UX, mwah, love it. Right? But it gives you control. And sometimes you'll find folks have thought of this. Maybe they'll just delete the contents of the hooks folder or something, right? But hey, surprises for them. Submodules are really badly understood. People don't really quite understand how they work. And essentially, you can do the same thing. You can set a post-checkout hook. That'll get called when folks do a Git submodule update. And it's a lot harder for defenders to kind of clean that or make sure that they're not executing those hooks. So this scenario was a little bit different. Actually, it relied on the way that the SaaS did it was to actually keep your working directory for your next time around that they needed to do some work. The idea being, hey, let's not go fetch all those external resources and download those dependencies. Let's keep that all to hand, right? But they didn't figure that once you got control with your little bit of code in your Git repo, that you'd go ahead and add a malicious hook that would fire when they did a submodule update. And so as you can see on the bottom there, when they do that, boom, they go execute whatever you've set it up with, in this case, a reverse shell in bash. Yeah, this is a very fun exploit. In fact, I find all of them fun. That's just me. Really, I mean, the best mitigation here is why run Git as root, right? You don't want to do that if you can. You just really don't. Caveat, I have seen situations where you actually still do want to run things as root for reasons. So if that's the case, this is really robust way to mitigate. You can put that little -c command, -c there to override the core hooks path. So basically say no hooks, and that totally works. But it doesn't. It's actually not an accepted parameter on all Git commands, so it gets a little bit futzy. But yeah, it's very robust. All right, this is the last category of things. It's as old as the hills. It pretty much comes with Linux, and it's everyone's familiar with Windows DLLs, I'm guessing, like ways to reuse code across apps, so you don't have to reinvent the wheel every time, right? Linux has the same. Shared libraries, and it has a debugging tool that ships with your OS, and you can't turn it off for preloading these things. And why would you want to preload? It's really, you're the engineer, you want to just take over some stuff, run some init code before the executable you're examining runs. You want to override like what library methods behaviors have when they call them. It's pretty crazy stuff, and it just involves the environment variable and control of the disk. So I got to say, super fun to get this to work on a SaaS. Lots of fun. It relies on being able to control that LD preload variable. So here's an attacker saying, hey, go run some code for me. By the way, I'm going to need this environment variable, LD preload. Cool, just trust me. It points to the eventual location where you check out my Git repo. And you've precompiled an evil SO, a shared object. It's another name for the shared library. And you've targeted the correct architecture, so this thing actually works. And then if root checks out your Git repo, cool, 5 minutes, and sets that environment variable, which that's the game over moment, and then executes starts any process at all, you are out of luck. Yeah, bad things happen at that point. I suppose the bad news for attackers here is you have to write C code, as far as I'm aware. This is not easy to do in any other way. It's also really hard to find good documentation for this, but if you have this fragment there, that is all you need to go start looking. And yeah, you have to write C. So mitigations here, I mean, again, like, don't be taking untrusted environment variables and setting them. I've only talked about LD preload. There are other LD ones you do not want to set either. And I challenge folks to know what all the other dangerous flavors of node underscore whatever environment variables that can be set, right? You generally don't want to be messing with this. And the really bad news is you can't disable this behavior, right? I mean, you could try. Come talk to me afterwards if you're interested. And as a bonus, like, you might be forgiven for thinking, like, yeah, it's only like really fresh startups that make these kinds of mistakes. No. You can find LD preload issues in a lot of places, as regularly published CVEs will tell you. So there's a really good Kubernetes threat detection bit of software. Totally recommend it. They have on-host detections. So if you go as an attacker, you compromise a Kubernetes pod. Awesome, right? You have a mechanism to upload your own foreign executable you want to execute. As soon as you do that, as soon as you go and execute that binary, this threat detection software is like, whoa, you did not ship this executable with your base image. Like, oh, ho, ho, ho. And then it fires a really great critical alert with a great title that really tells your threat team, like, you are in a lot of trouble right now, right? So, spoiler, yeah, that just doesn't do anything if it's LD preloaded. Yeah. So really, I guess what's the moral of the story is there's so much to think about if you're defending, right? And this is one of those things. There's a whole bunch of research for doing stealthy things in Kubernetes that you can then do if your initial vector wasn't detected. Yeah, so a lot of good research. If you just Google syscalls eBPF talk to talk, you will find good stuff. And yeah, I brought this up with the vendor. They were very, very happy and very friendly and awesome about it. All right, so what do you got in the way of detections? I have a long list. I recommend the top things on this list. You want canary tokens because, my God, you are not going to get flooded with noise, right? I see people taking photos. You should go to canarytokens.org. They will give you AWS canary tokens. They are amazing. You can also craft your own with a little bit of creativity. Like, you can create some valid Kubernetes surface account credentials, leave those lying around in a predictable path, make sure that those credentials can't do anything, and then you can alert when that when Kubernetes API is interacted with, right? That's really solid. So I encourage a lot of that kind of thinking, like what would catch us, what would help post-compromise? And then you got a lot of infrastructure-specific threat detections are good. In defense of the vendor from the previous slides, they have a full suite of offerings, right? You don't have to just stick to their on-host stuff. And if you did use their full suite, you would be fine. Cool. So in summary, I hope I scared you a little bit, and I'm stopping right now. Thanks, folks. Thanks very much.